All right, so the topic that we're starting today is functions, and I realize that most of you, hopefully all of you, have studied functions in some form or another at some point. But I'm basically, for the most part, going to start from scratch. Maybe try to speed things along a little bit faster than I otherwise would, but I do want to spend a significant portion of our time just sort of motivating functions and talking about good practice with functions and things like that. So I would start by saying, well, reminding you, I guess, about these 4 items. I'm pretty sure we talked about those in one of our previous lectures. Those are sort of the goals of good programming practice, at least in terms of style issues. And so basically, the reason we have functions is to work towards these 4 goals. You know, theoretically, we could write all of our programs, no matter how long, without using functions at all. But using functions just helps us to meet these 4 goals of computer programming. So just keep that in mind. This will come up as we're going through our discussion. So I want to give just a couple of analogies for what we're trying to accomplish with functions. The first thing I want to talk about is the idea of a function as a module. We really want our programs to be made up of modules. And so I think one good way to think about this is to think about the components in some sort of an electronic device, computer, television, something like that. You know, 100 years ago, if your TV stopped working, you might take it to the repair shop and they might, you know, investigate to see if there was a wire that became disconnected, or I don't know. I'm certainly not an expert here, so I'm making this up a little bit. But you can imagine maybe there's some sort of a bulb in there that got burned out and they have to replace or something. But nowadays, everything's in what you could call modules, right? So, for example, if something's wrong with your computer, your laptop, the repair person might say, okay, you need a new hard drive, or you need a new memory module, or you need a new battery. You're probably not going to be going in there and resoldering things, right? So that's sort of the goal with our functions. We want to have our program made up of these sort of completely independent and self-contained modules that we can connect together in the right way and get things to work. And if we do that well, then we make our programs easier to read and understand, easier to debug, easy to modify, and so on. I'm going to say modify / maintain here. So that's one analogy. Another analogy that is often talked about in computer science is the black box analogy. So ideally, what we would like is we would like our functions to be like black boxes, in the sense that we get them to work and then we no longer care what's inside them. We don't have to look inside anymore. We just know what it does. And we also know something about what goes into the black box and what comes out of the black box, so that we know how to insert it into our program so that it does what it's supposed to do. But the point being, these black boxes have to be completely independent and self-contained, other than this carefully defined input and output, so that we don't have to, for example, try to figure out what's wrong in one box if some other box isn't working. All right, anybody want to comment or question so far? So if we're going to use functions in this way, we're going to have to change the way that we've been looking at programming. And I'm kind of speaking to you as if you had never seen a function before, right? So up until this point, basically, when we wrote our programs, we would say, okay, here's step 1, here's step 2, here's step 3, here's step 4, here's step 5. And when we get to the end of all of our steps, then we're done. What we're going to have to do now, instead of that, is we just want to ask ourselves, what are the 3 or 4 or 5 major steps involved in accomplishing this task? And then once we have them down, we're going to go back and fill in the details on each of those 3 or 4 or 5 main steps. So this approach to programming has a couple of names. We can refer to it as top-down programming. Sometimes it's referred to as stepwise refinement. So the goal there is that when we're writing, say for example, we're writing our main function, instead of putting down every single detail right there in main, we're going to just come up with the 3 or 4 or 5 main steps that we need in order to get the job done. And here's the important point. When we're done with that, we need to be able to look at our main function and say, okay, yeah, if I accomplish those 3 or 4 or 5 big subtasks, I can see that then I will have accomplished the overall problem that I'm trying to solve. All right, so just to kind of give you an example, let's talk about a quote computer program unquote that we might write if we were trying to write a computer program to bake a cake. And so up until this point, we haven't been using functions. And so we might come up with something like this. I cheated a little bit and pasted it into the document ahead of time. Right, so every single little tiny detailed step has to be listed out one at a time, right? Open the cupboard door, get out a baking pan, open the refrigerator door, remove 1 egg, and so on and so on, right? So what we would want to do instead is just try to write 3 or 4 or 5 main subtasks that would also accomplish the task of baking a cake. So one option would be to do something like what I have down here at the bottom. Step 1, gather the ingredients. Step 2, mix the ingredients. Step 3, bake, right? So you can look at those 3 steps, and not that I'm an expert on cooking cakes, but I think that you can look at those 3 steps and say, okay, if I do those 3 things and I do them correctly, then I will be done with my task. So now all that's left is I need to go back and specify what exactly is involved in each of those 3 steps. Okay. All right, any questions? We're going to kind of start moving towards a real C++ example now, but I just wanted to sort of put that out there as sort of a foundation for what we're going to be talking about coming up. Okay, so here's our first actual C++ task that we're going to do. And basically the idea here is that we want to learn about how to use functions in C++. And so I've come up with just like the absolute simplest possible example I could think of, so we can focus on the functions part of it and not have to worry too much about the actual task itself. So we're going to write a program that draws a box. Okay, you can see that that is a box where I have used X's to draw the lines. in this case, this box is a 6x4 box, right? Looks like I have a width. The width of that box is 6, and the height of that box is 4. Okay, so if we were doing this without functions, we might start by saying, okay, I'm going to have 4 cout statements, right? One obvious problem with just having 4 cout statements is that then it becomes fairly difficult to modify my program to have it be a box with different dimensions. But besides that, we're going to attempt to use the techniques that I've just been talking about, top-down programming. So anybody want to just take a shot at telling me what, actually just one more thing of introduction before I go there. Just keep in mind that we're dealing with the console window here, right? So whatever the steps that are involved in getting this task done, I'm going to have to basically start from the top and work my way down. I can't, like, for example, draw the bottom line first and then draw the right line or something. So anyone want to just take a shot at what the 3 or 4 or 5 main subtasks would be in getting this job done? No worries about getting it right. At this point, it's just putting something out there so we have something to talk about.
I think for the function, like including parameters that take width and height could be useful.
Okay, you're absolutely right about that. I'm gonna be a little bit facetious here for a second, but I'm kind of building up to that, right? So at this point, we haven't really, if you've never heard of a function, then you probably don't even know what a parameter is. And so I'm not really even looking at computer programming yet. I'm just talking about, okay, even if, I was giving you a piece of chalk and telling you to go do this on the chalkboard, what would the 3 or 4 or 5 big steps be? Like I'm gonna have a list of steps here, and when we're done accomplishing these 3 or 4 or 5 steps, we're gonna be done drawing this square on the chalkboard or whatever.
Oh, okay. Maybe you could start with like drawing the first line of the box then, which would be like, I don't know, like printing.
That's all you got. That's it. Yeah, okay. That's it. Draw the first line of the box, right? That would be a good first step. Excellent. Anybody else want to take a shot at what might come next? By the way, just backing up a little bit, part of the skill of using functions effectively is sort of deferring on some of those details, right? I don't have to figure out all of the details yet. At this point, I just want to get it down that I'm drawing the first line of the box, and then creating my outline, and then I'm going to go back and try to fill in some of the details. Anyway, any other suggestions for what comes next?
Draw the middle lines with the spaces between.
Okay. With the spaces in between. That works for me. And then what would be the last step? Someone else take a shot at last step.
Maybe draw the last line.
Yes. Whoever was just speaking, I just barely hear that, but draw the last line. Okay, good. That works for me. That's a good starting point. I think it's pretty clear that if we successfully define what we mean by each of those 3 subtasks, then we will have accomplished our goal of drawing the box, right? By the way, let me so I'm going to digress for just a second here. To just in terms of my philosophy about class participation is, in my ideal world, everybody in the class will say exactly the same amount, right? So I know that's even more difficult on Zoom than it is in person. But I just want to throw that out there so that if you are one of those people who likes to just sit back and watch, just a little nudge to maybe try to get involved. And if you're one of those people who likes to answer every single question. Feel free to sort of give other people a chance. One of the reasons I say that is I know that sometimes I get students in my classes who feel like, how can I say this? The reason I ask questions is I want to find out who in the class knows what's going on and who doesn't, right? But really the reason I ask questions is because I want to find out what people are thinking, and I want to get people thinking. So, and then the other result of that is that I'm totally fine if there's a long pause. You know, if there's a long pause, don't feel like, oh shoot, there's a long awkward pause, I need to say something. If there's a long pause, I think that's good. Everyone's thinking hard about this. So anyway, end of digression. Okay, I want to just see if we can refine this a little bit. I have a couple of suggestions. The first thing I notice is this is great, but step 1 and step 3 are really the same task, right? So we don't really need to define what it means to draw the first line of the box and then also define what it means to draw the last line. Those are the same tasks. So probably we should try to think of a name that we could use in both positions, right? I mean, I could say, instead of saying draw the last line here, I could say draw first line of box again, right? And that would solve the problem that I just suggested. But then that doesn't really make sense either, because when I'm on step 3, I'm not drawing the first line of the box. So the principle that I'm going to suggest here is that when possible, it's better to use a name for my subtask that is more general and less attached to the actual problem I'm solving, because then it's easier to reuse it later. So I'm going to suggest something here like that just describes what the function is actually doing, not the context of drawing a box, right? So what the function here is doing, or what this subtask really is it's just saying, I'm just saying draw a horizontal line, right? That makes sense what I'm doing with that? I'm generalizing it. So it just describes what is actually being accomplished there. Cool. Okay, and then I want to do kind of the same thing with draw the middle lines with the spaces in between. That's obviously, I'm giving that function, that task or function, a name based on what it's doing in this particular application. But more generally, all I'm doing there is I'm saying draw two vertical lines, right? So I'm pretty happy with this now. I think it's still clear that if I do those 3 subtasks, I will have completed my task of drawing a box. And I've used some general purpose names so that I can reuse those functions again easily if I need to. All right, so I'm ready to actually put this into some C++ syntax, unless anyone has a question or a comment before I move in that direction. All right, so we're turning this into a program. So let me make this into a comment. And we'll get rid of that. Okay, so basically what we're going to have here is we're going to have 3 function calls in main. Oops. In C++, the way that you have a function call is you put parentheses at the end of the function name. That's how the compiler knows that this is a function call and not just a variable sitting there. And then as with all other statements in C++, you're going to end these statements with semicolons. Okay. So here is the actual C++ syntax for what we're trying to do here. We're saying first draw a horizontal line, then draw 2 vertical lines, then draw a horizontal line. What this means is go execute the statements inside this function. When you're done, come back and continue on with the next statement in main, right? Which would be, all right, now go ahead and execute all of the statements inside the draw 2 vertical lines function. When you're done with that, come back and continue on with whatever's next. So obviously what we have left to do is we need to actually write or define those functions, draw a horizontal line and draw 2 vertical lines. Just to get a little terminology in here, this is called a function call, but most people are probably usually going to say, if you want to use the big fancy word for it, you could also call this a function invocation. You're invoking the function. Okay. All right, so all that's left now is we need to go ahead and actually define those 2 functions. In C++, the way we define a function is we start with the word void, and then we put the name of the function. I think that's the same as Python, except instead of the word void, you put the word def, D-E-F there, right? If I'm remembering correctly. And then just like when we do a function call, we have to put parentheses after it. And then we can put the statements that we need to put here to define the actual function. So drawing a horizontal line is just going to be okay. Any questions about any of the syntax going on there? As usual, same thing that we did with loops and if statements in C++. You have to start your function with an open curly brace and end it with a closed curly brace, unlike in Python where you just know where the function begins and ends according to the indentation. Drake, you want to go ahead and ask your question?
Yeah, so if I wanted to use a variable in this function, would I put the variable inside the parentheses like you would in Python?
So that's kind of if you wanted to have a variable that was initialized by the calling function, then yes, you would put that in the parentheses. Hang on to that thought though. There's a lot going on there and we're going to get to that in a minute, okay?
Gotcha.
All right. All right, any other questions about what we have here so far? All right. So all we have left to do now is we have to define our draw 2 vertical lines function. Oh, by the way, let me just back up a little bit here. I'm going to go ahead and just say that what we have here is, you've got the word draw horizontal line here, where it's a function call. Then you've got the words draw horizontal line again here, but here it's not a function call, right? It's a function definition. Okay, so just a little more terminology there. I was going to say something else right out of my head. So let's go ahead and define our draw 2 vertical lines function now. And what you're going to see here is that I'm going to continue with this idea of top-down programming rather than just hammer out all of the details right here. I'm going to see if there's an opportunity to call on a subtask as I am doing this. Okay, so that's a pretty important skill to develop as you are doing your programming. Just sort of knowing when's a good time to say, okay, what I'm about to do is something that I can easily think of as a separate task. And so I'm going to just create a different function for it. So let's watch how that happens. So the first thing I notice is that, so what the draw two vertical lines function is going to do is it's going to draw these two lines. I'd like to make it easily modifiable so that it could be 7 rows instead of 2 rows. So I'm going to use a for loop, and each time through the for loop, I'm going to be printing out one of these rows. Makes sense? So each one of these rows is basically just an X with some spaces and then another X. And so my for loop is going to go I only want 2 rows for the picture I've got there, so I'm going to put 2 here. But notice that I could easily just change that to a 7 and I'd have 7 rows instead, or whatever. Okay, and so what I want to be thinking to myself now is, all right, I've got this for loop set up, and whether you type it out or whether you have it consciously in your brain, this should be something that you are intentional about. Okay, what needs to happen inside this for loop? I'm going to say, well, what needs to happen inside this for loop is I need to draw one of those rows, right? So you ought to be able to look at this code now and say to yourself, okay, I'm feeling pretty good. If I can insert some code to draw 1 row right there, then I'm done with my whole program. I can look at my draw 2 vertical lines function and I can say, okay, if I do this, what I've typed here, I will have accomplished the task of drawing 2 vertical lines. So one option would be now to just start typing the code here, right? All of the details. But what I'm going to suggest is that we use our stepwise refinement / top-down programming skills and just call a function here. Okay. So now what that means is that we're done with our draw 2 vertical lines function, but I'm going to have to go define a function to draw 1 row. Okay, so draw 1 row, it means I'm just drawing an X and then some spaces and then another X, right? So here's my X, and then here's my spaces. How many spaces? 4 spaces, right? All right, how are we doing? Any questions about any of this? I have a couple of syntactic issues to talk about with you, but aside from those, I believe we are actually done now. We've got a function that we've got a program that's going to draw a box 6 by 4. Do I need an? Oh yes, I do need another X. Thank you. Okay, here's the other syntax detail. And this is a little bit of an idiosyncratic thing about C++, but it's really straightforward. There's nothing conceptually difficult The problem here is that just like with variables in C++, with functions, you also have to declare them before you can use them. Okay, so what that looks like is this. I'm going to take my function header, the function header being the first line of the function definition, and I'm going to just copy paste to above int main and put a semicolon at the end. There's my function declaration. Let me do that with every single function definition. Copy. And if you can copy paste, you can do these function declarations. Okay. So this is now a third instance of the words draw horizontal line, right? We had it here where it was a function call. We had it here where it was a function definition. And now we have it here where it is a function declaration, except no one really uses the term function declaration. Normally we just call a function prototype. But actually, we don't even need to say that, we just say prototype, typically. Okay, so 3 different contexts in which the word draw horizontal line is used, just to kind of point some things out syntactically, because sometimes beginning students have a hard time keeping track of all of this. So I should say beginning C++ students. Just let me point out that in the function call, there is no void, right? You don't put the word void in there, but you do need a semicolon. In the function definition, you do need the word void, but you don't need a semicolon. And then in the function declaration, you need both. You need the word void in front and you need the semicolon at the end. All right, any questions about any of that before I give this a roll?
I have a question.
Okay, shoot.
So if you define your function above the main, do you have to declare it?
If you define your function above main, then you do not have to declare it, but that's not a good idea. In C++, what we do is main is always the first function in the file, and then we just use prototype, so we don't have to worry about what are the definitions are in.
Okay.
You can imagine that if you've got a program with 1,000 functions in it, you don't want to have to worry about making sure that every function that calls another function is below that function in the file, right? And another reason is just simply that this sort of models what we're talking about here with top-down programming, right? We're starting with main, which is the most general, and then we're sort of drilling down to get to the details. I think that's all I wanted to say about that. Yeah. Okay. So doing it this way, basically, we just think of a C++ program as being a collection of functions, right? And it doesn't matter what order we put them in, at least as far as the compiler is concerned, it doesn't matter what order we put them in. They're just all equal functions. The only difference is that this function called main is special because C++ knows that's where to start, right? Not because it's the first function in the file, but because it's named main. One other thing to just point out is it should be unexpected, given what I've told you so far, that the main function has the word int in front of it instead of the word void in front of it. And we will talk more about that on Wednesday. But for now, I would just say that's really just an artifact of history. You should think of that as being the word void there, even though it's actually int. And the reason it's int is just for historical reasons. If you take Java, you're going to find out that main is not int in Java. Main is void in Java. And in C++, just for historical reasons, we have to keep it as int, but we really think of it as if it was void.
Just a quick question about that. Is that when in the compiler it gives you exited with code 0 or code 1? Is that the integer it's talking about, or is that
Yes,
unrelated?
that's exactly the integer that it's talking about. Yeah, so, and we'll talk a little bit about that, a little bit more about that on Wednesday, but yeah, that's basically what we're talking about. All right, trying to think if there's anything else I want to say here. I guess I already sort of talked about the fact that main is just, we haven't really talked about the fact that main is a function before today, but now that we've studied functions, I can say, oh, main is just simply a function in C++.
Question.
Yeah.
Okay, so for the three functions, you used three different variables. You used count, row count, and space count. If those were to all be the same word, would it screw things up?
No, that would be fine. And again, I mean, this is great that you're asking these questions. And also, we're going to be getting to all of this, but that is what I want to emphasize about that is that even if I called them the same thing, they would still be completely unrelated, separate variables.
Okay.
You'd have a count variable that was draw horizontal lines count variable. You'd have a count variable that was draw two vertical lines count variable, and that would actually literally be a completely separate memory location in your computer's memory, separate variable, not related. But anyway, and the reason I called them something different is not because of that, right? The reason I called them something different is that in each case, I was trying to think of the best possible, most descriptive name for the variable. Okay. If it turned out that the best possible, most descriptive name for the variable here was count, then I would have just called it count. Regardless of the fact that there happened to be another separate independent variable up here in the count. But we will talk about all of that in much more detail. All right, so let's give this a roll. Oops. And there's our 6x4 box. Okay. Any questions about anything so far? All right.
Can I
Oh,
ask
go
a
ahead.
question about the draw one row function?
Sure.
I was just wondering, so like at the beginning of the function, it prints the X and then like 4 spaces, and then it prints that like second X and then goes to the beginning of the end line.
Mhm.
So wouldn't it just go back up to the like row 39 and then just print like the 4 spaces without printing the X? Or does like, where does like the third X get printed if the like X on 38 isn't included in the for loop?
I'm not sure what you mean by the third X. So let me just try to, maybe I'll just try to go through it. And then if that doesn't answer your question, you can try it again. But so this draw one row function is doing, for example, this part of the output, right? So this prints that first X that's on the left margin. And then we've got a for loop that gets executed 4 times. Each time through that for loop, we print 1 space. And so after this for loop is completely done, we're at this position right here in the output, right? And so we just have to print 1 more X.
Oh, okay, I didn't realize it was just printing 1 row of the 2 X's, but that makes sense.
Okay. Cool. All right. So we're sort of at a major stopping point here. No, I don't mean stop, transition point. That's the word I was looking for. So I just wanted to see if there's anything else you want to talk about before we transition. Okay. And as usual, it appears that I'm drinking lots of coffee right before class. And so I'm going to just have to take a little 2-minute break here. So let me pause the recording and I will be back in probably less than 2 minutes. Okay. All right, here's our next task. Oh, I do just want to say one other thing. This is one of my little idiosyncrasies. I just think that programs are way easier to read if you space your functions out a little bit. And part of that's because oftentimes I'm the one doing the grading of them, and I find them a lot easier to grade if they're spaced out a little bit. So in the style conventions, you're going to see that I require 6 blank lines between each of these function definitions. I just want to say that I'm not going to be demonstrating that often during lectures because when you're teaching and learning about this stuff, it's just easier if you can see everything on the screen at the same time. So I'm going to just put 1 blank line between each function. Just want you to know that that's not what I would be doing if I was writing this program for other people to read later. Okay, so here's our next task. What I want to do now is I want to make it so that instead of always making a 6x4 box, I'm going to ask the user to enter the width and the height of the box. So main's going to look something like this now. And I guess I should just throw in one more caveat too. You know, you see these numbers here, the 6 and the 2 and the 4, and I'm pretty sure we talked about in lecture. If not, it's in the lesson and in the style conventions that that's not a very good practice, right? We want to try to avoid numeric literals in the code as much as we can. So I'm just putting that out there as I'm going to actually leave those for now in this example, because I'm going to be getting rid of them in a second anyway. But I just wanted to emphasize that, you know, that's probably not something you'd want in your final code. All right, so we've got width and height, and then we're going to say cout enter width, and width, cout enter, enter height, and height. Okay, and now because you have all worked with functions before, my guess is that you're probably going to notice something wrong with this, but just bear with me for a second. Basically, what I need to do now in order to draw a horizontal line to do the correct number of X's in the line that it's drawing is whatever the user entered for the width here, I want that to go here, right? So I could just say width. The problem with that is that that completely throws everything out the window that we were talking about with functions being like black boxes or modules, completely independent and self-contained, right? Because now I've got this variable width, and this function doesn't work unless main knows to make sure that width is the right value. So main and draw horizontal line have to coordinate. And that may not seem like a big deal to you now because we've got this little tiny program and I'm only talking about 2 functions. But the reality is that if we allowed that in our programs, often things would get really messy really fast, and it would be really hard to debug or modify my code. Little digression, just have to tell you, I have personal experience with this because back in the day when I first started writing computer programs, I was sort of self-taught, and I ended up writing this big, long in the sense of one high school student writing it, program that was sort of just like a text-based adventure game sort of thing. And I literally got to a point where I could not get everything to work perfectly because I would fix one bug, and as soon as I fix that bug. It would cause something else that was working before to stop working because I wasn't following this principle of having completely self-contained and independent functions. So for me, this is an easy sell. And hopefully you can see the benefit also. So this is not how we're going to do things. In fact, as it turns out in C++, we can't, at least not the way I have things set up now. If I try to compile this right now, C++ is going to tell me that width is an undeclared variable. So what we're going to do, because we're not going to allow functions to share variables ever, is we're going to have functions communicate with each other about values and variables. To be more precise, we're going to have main, which is the calling function in this case, send a value to draw horizontal line. And draw horizontal line is going to store that value. Okay, so let me back up a little bit here and let's go through that process. You've probably done this in Python, but I'm being like super painstaking here about doing it carefully and doing it well. Okay, so my suggestion is what we're talking about here is communication between main and draw horizontal line, right? Draw horizontal line needs to get some information from main. So the best way to do this is to start thinking about it from the perspective of the called function, that's draw horizontal line. And I'm going to pretend for a second that I'm function draw horizontal line, and I'm going to think, okay, I'm function draw horizontal line. What do I need in order to accomplish my task? And I'm going to think to myself, all right, well, so my task is to draw one of these lines, right? Okay. Now, if you're not careful, you may answer that question by saying, oh, I need to know the width of the box. But I think if you're being more careful about keeping your functions independent and self-contained, remember, draw horizontal line isn't necessarily going to be drawing a line in a box. I want to keep this function general so that it's just drawing a horizontal line of x's. And so I think about it that way. What I need to know in order to do my job is how many x's to print. That makes sense to everyone? Any questions about what I'm trying to do there? Okay. So here's how I do that in C++. Okay, so what this means when I put this variable declaration in the parentheses here, that means that, okay, I am going to be creating this new variable called numx's that's only going to be known inside the draw horizontal line function. And it's a little different from other variables that I might declare, because instead of just being garbage when I first declare it, it's going to get an initial value based on whatever value was sent when draw horizontal line was called. Okay, so for example, I could put, 13 here in the parentheses. That would be perfectly valid. And that would mean that when draw horizontal line gets called, a new variable named numx's is being declared, which means I'm actually allocating a memory location on my computer someplace for that variable. And I'm going to start off with that variable going to be equal to 13. Realize I messed up my grammar there a little bit, but I think you got the point. Okay, so what we really want here is width, right? Whatever the user entered for the width, that's how many x's we want the draw horizontal line function to print. So what's going on here now is when I get to this point in my program, I'm saying call the function draw horizontal line. And when you do, send it whatever value is stored in the variable width. Okay, so if the user entered 9, then what's being stored in the variable width here is 9. So what's going to get sent is 9. And so this num x's variable down here and draw a horizontal line is going to start out life being equal to 9. Anybody want me to say that again? Have a question? Okay, so hopefully it's clear at this point that what should go there instead of a 6 is whatever num x's is. Okay. Any questions about any of that? All right. And then obviously the same thing for the second time we call draw a horizontal line. We also want to send that same value again, because we want the horizontal line to be the same length. All right. Let's just, what I'm going to do now is I'm just going to go down my program and I'm going to go through that same exact exercise with my other two functions. Actually, let me back up just a little bit and do some terminology here, okay? When I've got this variable declaration in the parentheses here, that's called a parameter. Okay, and then here's a principle, a C++ principle that I really want you to burn into your brain because it's going to help you out later on when you get confused about exactly what the syntax should be for when you're trying to create a parameter. Parameter is always a variable declaration, okay? So whatever the syntax was when I declared an int variable up here, it's going to be exactly the same syntax down here in the parameter. All right. So I guess I just also have to say I may be simplifying that a little bit. There may be some cases later on where things are a little more complicated than that, but that's a good principle to hang your hat on. And then you can learn about when there may be some minor exceptions to that. Okay, if there's no questions about that. Oh, just one more thing. Down here in the parentheses in the function definition, we call that a parameter. In the function call, when we call the function, we call that an argument. Okay, so width is an argument here. Num_x is a parameter here. And so to use those terms to explain the process again, what's happening is that main is sending the argument width. Draw horizontal line is receiving that value into its parameter num_x. All right, so let's talk about when main calls draw two vertical lines, right? So now we're talking about the communication that's happening between main and draw two vertical lines. So I'm going to start off, as I suggested, with the called function. I'm going to pretend that I'm the function draw two vertical lines. And I'm going to ask myself, okay, and you could kind of think of this as like if I was a person, right? And I had a piece of chalk and I was supposed to draw two vertical lines. What do I need to know in order to correctly draw those two vertical lines that you see there? Anybody want to suggest what I need to know? So just to clarify, when we're doing this exercise, we're trying to completely forget about the rest of the program and the context. I'm just focused on writing a function that's going to draw two vertical lines. And I need to know what is it I need in order to do that job.
Width.
Okay, well, I'm function draw two vertical lines. What do I mean by width exactly? So I would suggest that when I use the word width, I'm talking about a box, right? But here I am in draw two vertical lines. I don't know what we're talking about if we're talking about a box, right? Because my job is focused on just drawing those two vertical lines. Does that make sense? I hope I'm making sense how I'm trying to sort of take that out of the context of the drawing the box, because then number one, it becomes easier to reuse that function elsewhere. Number two, it actually makes the contents of the function itself make more sense. Anyway, sorry, I'm babbling. Anybody want to suggest something different that we might use there? The distance between the two lines. Yes, that's exactly right. So I would say, how would we quantify the distance between the two lines? Like, we're not measuring with inches here, right?
The height?
Well, so now I'm still not asking about how it's connected to Maine yet. I'm still asking
okay.
about, I need to know, that's correct. I need to know the distance. So I'm probably beating this to death a little bit, but I'm enjoying myself, so bear with me. I'm still talking about the distance between the two lines, which is the correct way to think about it, right? But how do I say what that distance is? So the answer I'm looking for is, I need to know how many spaces there are going to be between the two lines. That make sense? If I'm supposed to go up to the chalkboard with a piece of chalk and draw these two vertical lines, I need to know how many spaces there are going to be between the two lines. Okay. Is that all I need? So,
Can you do that for every row?
well, it's going to be the same number of spaces for every row, right? But the problem is, or the issue is, in this case, I've got two rows of these, right? But I want to be flexible enough. If the user enters, let me rephrase that. I want to be flexible enough so that maybe these two vertical lines are taller than just two rows, right? Did that make sense?
Yes.
So in addition to needing to know how many spaces there are between the two vertical lines, I need to know how many rows of X's there are going to be in the two vertical lines. Okay, so I apologize if I did that in sort of a really long roundabout way, but hopefully now you can look at this and say, oh, that makes sense. In order to draw those two vertical lines, I need to know how many spaces between them and how many rows of X's there are going to be, assuming that each of these is one row. Okay, any questions about that? Okay, so just to back up a little bit, we were talking about how main is going to have to communicate with draw two vertical lines. And we started with the called function, which is draw two vertical lines, and we figured out what draw two vertical lines is going to need to know in order to do its job. So the next step would be to go back up to main and make sure that main is sending that required information inside these parentheses, right? So now I'm in main and I'm saying, okay, I want to call the function draw two vertical lines. Draw two vertical lines needs to know how many spaces to put between the lines. Well, how many spaces do I want the draw two vertical lines function to put between the lines? And I think that's the question that Drake was ahead of us on there about 10 minutes ago or whatever it was. That's how many spaces we need between the lines, right? Now's one of those times when I really wish I could see everybody's face, because I can usually tell if everyone's completely lost, but I guess I'm going to go with that for now. And then the second thing that draw two vertical lines needs to know whenever I call it is it needs to know how many rows of these X's to make. And so in this case, the height was 4 and I needed 2 of those rows. So it turns out that I'm always going to need height minus 2 of those rows. Okay. So now we're done with fixing the communication that needs to happen between main and draw two vertical lines. Any questions about what happened there? Okay, so now what I need to do is I need to figure out what I need to modify inside the draw two vertical lines function. And so here I've got for row count get 0, row count less than 2. That's because I had 2 rows. But if I've got num rows instead of 2 rows, then I need to put num rows there. And now I just have one function left to fix. I need to figure out the communication now between draw two vertical lines and draw one row. Okay, so as always, I'm going to start with the called function. In order to do my job, if I am function draw one row, what I need to know is, so here's one row. In order to do that job, what I need to know is just how many spaces between the x's, right? So I'm going to say int num spaces again. Okay, and so this illustrates, unlike most of the situations, we're just going to use exactly the same name here. And the reason is simply because that's the name that makes the most sense in this context, number of spaces. And so instead of 4 here, I'm going to put num spaces. Okay. One more thing I need to do before this is actually a working program is I need to update my prototypes, right? And that's typically going to be, the last thing I do right before I hit the button to run the program again is go update those prototypes, just copy, paste, copy, paste.
Professor,
Uh-huh.
on the draw two vertical lines, the parameter num spaces, where's that being used?
Oh, good question. Right, so I forgot, I stopped halfway through, I got in a hurry, and we were talking about the communication between draw two vertical lines and draw one row. And I did the first step, which was figure out what information draw one row needs when it gets called. But then I forgot to go back to the calling function and make sure that I send that required information, right? So, or another way to put that is now I've got a function here, draw one row, and it says, when you call me, you need to send me one piece of information. And here I've got a function call to draw one row, and I'm sending it no pieces of information, right? So that would be a compiler error. But what I do need to send here is simply num spaces. Okay. All right. So very small program here, lots going on, right? So I really recommend that I'll be posting this on Wednesday after class. Take a close look at it, make sure you understand all of the nuances of everything that's going on here. But I think that even right now, I've got everything working. Oops. So that I could say, let's enter a width of 5 instead of 6. Oops. And let's enter a height of 7. Okay, so now we've got a box that has a width of 5 and a height of 7. All right, I think that's a pretty good stopping point. I feel like there was something I was going to mention, but if so, it has escaped me at the moment. Anybody want to ask any last minute questions or make any last comments before we call it a day? Oh, I was going to say, I think I might just go ahead and post this lesson so that if you want to take a look at it between now and Wednesday to sort of get yourself caught up to speed if you had a little trouble tracking everything. So I'll go ahead and post this as soon as we're done. So lesson 6 should be available for you to look at between now and Wednesday. Any questions or comments? All right, we'll see you guys on Wednesday.
Thank you, Professor.
Have a good day.